Okay, so for the digital and analog signals, the digital signals only occur in the ranges 0 and 1 or 0 to 1. They have only values of high or low, true or false, or on or off. 1 representing on and 0 representing off. But for continuous, they can move anywhere. This is an example of the digital signal as a graph. They can only be high or low, only be up or down, right? So you cannot find diagonals in their graphs. But for analog, they can go anywhere like that because they don't exist. They are not restricted by the ranges of 0 and 1. But for digital, they move throughout. Okay, so for a digital signal, normal to small noise will have the signal retaining its values. Hence, in the graph, it will retain its shape. But for an analog signal, this is not the case. Let's look at the example of the digital signal. So this is an example of a digital signal. Let's see, it's lying between the values 1 and 0 here. Now, small noise added to the digital signal. See, this is the small noise added to the digital signal. What's the small noise? You can see it still lies between the values of 0 and 1. So we can still detect the shape of the digital signal. Look at the analog signal. Let's say this is it. Right? And we know it lies between some values like, let's see, here is 5, so 4, 3, 2, let's say 1, just like that. So small noise, right, can move the value of the signal. Look here and here from one lane or one measurement to the other. But in the digital signal, this is not the situation because it ranges between the values of 0 and 1. It's either on or off. So small noise cannot just distort the shape of the digital signal. Now we have positive and negative logic. So for positive logic, the higher amplitude in your graph represents 1 and the lower amplitude represents 0. This is what you call positive logic. So if you reverse it, it's called a negative logic. So if your higher amplitude is representing 0 and your lower is 1, we call this negative logic. Okay, so now a bit is just a single digit in the binary form. The binary form is just numbers represented in base 2, which we'll talk about shortly. Now, you can group these bits. So just single numbers in binary form. A bit, okay, let's say a single bit like this, stands for some information. It holds some information. So grouping these bits, we have 4 bits now, to form a digital word. The digital word is still having some information because the form bits. Now, what are digital words? Let's use an example to explain. Imagine, no, let me use you. Let's say you like eating a lot, right? So we are usually found at Bush Canteen. Let's use B to represent Bush Canteen. You like eating a lot. Let's use E to represent eating. And you like to take 2 plates. Let's use P to represent taking 2 plates. Now, this B, E, and P are combined to form digital words, right? They are in the binary form, so they can be on or off. Now, let's use 1 to represent on, which means that activity is ongoing. And let's use 0 to represent off, which means that activity is not happening. So, B can be 1 or 0, on or off. E can also be on or off. And P can also be on or off. So imagine I want to locate you right now. And you are at the Bush Canteen, which implies B is going to be on. Yes, you are eating. E is going to be on. And yes, you've taken 2 plates. P is going to be on. This digital word is giving me this information that yes, 1, 1, 1, B1, E1, and P1, which means yes, you are at the Bush Canteen. Yes, you are eating, and yes, you have 2 plates. Just what's answer, babe? Babe. Babe. Okay, so that is the information the digital word is giving us. Now imagine, yes, you are at the Bush Canteen. Yes, you were eating, but you didn't have 2 plates, right? So let's say this is off. P is just equal to 0. Our digital word is now going to be what? B, 1, E, 1, and P, 0. This is giving us some information that you are at the bush canteen, you are eating, but you are not having to plate. So to form your digital words, you have to follow the instructions. Whatsoever instructions are given to you, if they are saying B stands for Bushki, you can create your digital words, right? So if you look at the example in this slide, they have W for windy. So if they say W for windy and windy is equals to 1, you know that yes, it is windy, right? So they have R, W, S. If it's 1, 0, 0, yes, it's raining because they use R to represent raining. No, it's not windy, and no, it's not. S is standing for, what are they saying? Sunny. It's not sunny. So you just follow the instructions and determine whether it's on or off to form your digital word.